When you pull on a rope, have you ever wondered how the force travels through the rope to drag the heavy object at the other end? Most people picture a force being transmitted through the rope like an invisible hand that grabs and pulls the object. But in the energy filament theory, things work a bit differently. The process isn't about a single force moving through the rope like a racing car. Instead, it's about the entire rope being transformed into a continuous pathway of tension. When you change the conditions at your end of the rope, it causes the energy filaments within the rope to reconfigure themselves. This reconfiguration changes the distribution of energy throughout the system and creates a new path that the heavy objects will inevitably follow. Let's break it down with a simple analogy. Imagine you're holding a slack rope attached to a heavy object sitting still on the ground. The rope hasn't yet interacted with the object. This state represents an equilibrium where gravity pulls the object downward and the surface beneath it pushes back with an equal force, keeping everything in balance. The rope, in this case, is like a passive player that isn't contributing to the system's overall tension. There's no slope for the object to move along, so it remains stationary, firmly fixed in place. Now, when you begin to pull the rope, you're applying tension at your end. The first thing that happens is that the segment of the rope closest to you tightens up. This tension creates a disturbance that ripples through the rope's fibers, transmitting the changes in the system's state. Think of it as a tiny internal command running down the length of the rope, signaling the fibers to adjust and align in response to the tension. This stage represents the process of clearing the path, where the rope is starting to react to your input. The critical moment occurs when the tension wave reaches the end of the rope, where the heavy object is sitting. The object feels the tug from the rope. For the object, the original position, where it was at rest, becomes like a sidewall. If the object stays at rest, the rope will continue to stretch and pull, creating a distorted tension pattern. However, when the object moves, the entire system of the rope, surface, and supporting structure adjusts in a way that makes the object slide in a more efficient direction. Essentially, the object moves to a position where the system's total energy cost is minimized. What you're seeing when you pull the rope is not just the object being dragged. The real driving force is the reconfiguration of the tension system. You are not physically pushing the object by force alone. Rather, you're changing the tension landscape of the rope, and this adjustment is what makes the object move. Now, let's take this concept further. If you were to imagine a sloped hill, the object, once pushed, slides down the slope because it is following the path of least resistance. The rope is like that slope, and the energy filaments are the intricate details that form the terrain of that slope. As you pull the rope, you're essentially creating a path of least resistance for the object to follow. It moves towards the most energy-efficient route that you've redefined through the rope's tension. The pulling force you feel, the sensation of the rope resisting your efforts, is really the result of your adjustments to the tension pattern within the system. When you pull on the rope, you are not just forcing the object to move but guiding it through a prearranged system of energy filaments. These filaments redistribute tension in such a way that the object ends up following a path that minimizes energy expenditure. What feels like a force is, in reality, a reflection of the subtle changes in the rope's tension landscape, which you've created by your actions. In simpler terms, the tension you feel in the rope is the system adjusting to the new conditions you imposed, and the object simply follows the path that makes the most sense for the entire system to balance itself out. Whether you're pulling a sled on snow or dragging a cart on a rough road, you're essentially changing the landscape of energy flow, guiding the object to a state of lowest energy. This process is not limited to just the rope. It's the same principle that governs many of the interactions around us. It's the same principle that drives the movement of the planets, the flow of light, and the interactions between particles. The universe is constantly finding the most efficient way to balance tension and energy. Next time you pull on a rope or see something being moved by a force, think about the underlying process at play. It's not just a force pulling on the object, but a complex system of tension adjustments that guides the object to move where it needs to. The visible motion is just the result of these deep, subtle changes in the system. Tap follow, Share it on New Physics, Clear Universe.